Hello, my name is Mark Biasotti, and in the next few minutes I'm going to introduce you to a powerful new SOLIDWORKS feature called Freeform, and how you can use this feature to help you solve challenging design problems. In this demonstration I'm going to be building a boat hull. Traditionally, boat hulls are built using a number of cross-sections that are first calculated on a drawing, using values to determine the cross-section of each placement as it goes from the aft to the stern. In this case, I have a drawing that describes this, but I don't have any 2D geometry. I want to quickly visualize this boat hull design, so I'm going to take this drawing and exploit it by using our sketch picture feature to paste this drawing into our 3D part and use it as reference as I build my freeform against it. So here's how I created this. I created a number of reference planes using reference plane offset with the copy option feature, and placed my first side view of the boat in that right plane. And then in each of the offset planes I created a sketch picture and placed that sketch picture identical in each of those planes. Let's show you one of them. Let's turn off the transparency. You see that there's drag handles that we can drag those around with, but also we can input numerically the X, Y, rotate, and scale values. Since each of these is identical, I know these numbers and I entered them for all of them. With the transparency, I assigned a user transparency of the white surround and then used that white as the part of the sketch I wanted to show transparent. So let's turn these off temporarily and then create our first surface, which will be a boundary that will be the basis for our freeform surface. I'm going to pick my first directional curves here and then some second directional curves that I created, and then use the trim by second direction to get my primary surface. Let's complete that. And now I can assign a freeform to this surface. Turning on my sketch pictures again, I can start to adjust this surface to those sketch pictures. You can see the mesh that comes up. Let's just turn these off temporarily so I can show you to assign the boundaries. Here I'm going to make the back tangent. The bottom I'm going to make movable because I want to move the nodes and control the UV of the surface. I'm going to leave the last two at contact. So let's show our sketch pictures again and go to our side view, and let's start to assign our control curves that will go through these various reference planes. So I can select add curve through the property manager or through the right mouse button and start to place those through these 5 planes. So I'm going to start with plane 11 and then go forward and complete control curves for each of these reference planes. Now that I have those placed, I can start to adjust them. So I'm going to grab the bottom control node and the vector and use our triad to move that to make them more planar with my reference plane. So using the triad I can easily adjust these to be planar, and I'll do that for each of these. Again, dragging back the bottom control node, adjusting the vector using the triad, and I'm only going in one direction here so that I can keep it planar. Let's jump forward, and now that we have those in position, we can now adjust them to the sketch pictures that we place. So dragging the control nodes in vectors, we can match them to our sketch picture. And we'll do that for each of these by dragging our triad and matching our sketch pictures. And we'll finish with this last one. And this one I think I'll just drag the front top vector to match that. And now we have our surface roughed in. It's close to these sections, but if we turn on our mesh, you can see there's some deviation going from the front or the back to the front. So I'm going to add additional control curves going in the second direction and use those control curves to normalize my sections going from the back towards the front. So I'm going to have a curvature comb to help me analyze that, to do some fine adjustment. So I'll take and start to control these nodes and watch my curvature comb to make sure that I'm getting a fairly normalized rate of curvature. I can also use our property manager over here that has thumb wheels to control these vectors for the triad. This gives you much more precise control. I can use my Alt key to half the value as I twirl the knob, and then the Control key to double that value. So with a bit more adjustment here, let's go back to my first directional curve towards the front here and adjust this a bit. I can start to really understand the fairness of the surface, especially with the mesh, and adjust each of my points to be smoother and get a better transition as it goes between the control curves. So let's jump forward and let's just finish out the front of our side of the hull with a fill surface. I'm going to use this reference surface edge as well as the freeform edge and then the front curve of the side view and build a fill surface. I'm going to make the transition between my freeform and my fill curvature to get a nice smooth transition, and then complete that. Hide my reference surface here. And let's go ahead and mirror this from the front to the back since it's symmetrical going in that direction. And then mirror it one more time across the right plane. So picking my right plane, I'll pick the body I created and mirror it across. And now you can see I have a gap where the keel of the boat is. I'm going to fill that using a boundary surface. So simply picking these curves from my first direction first curve and then the first direction second curve, I build a simple boundary between those two mirrored freeforms. Now all I have to do is basically close it off. So I'm going to use a fill on the top, pick all these outer edges and fill that in with a fill surface. Now all I have to do is knit all of them together and use the solid feature, and now I have a solid boat hull. I'm going to go ahead and shell it by 1/2 inch, and now I have my finished shell of the boat hull. Let's turn on our zebra stripes. Looks pretty good. There could be a little more adjustment, but we're getting a pretty good continuous surface there. This concludes our demonstration of Freeform. To find out more about Freeform and other powerful SOLIDWORKS features, feel free to visit our website at www.solidworks.com and learn how SOLIDWORKS can help you design better products.